Hello everyone, and welcome to another video with Special Maths Academy. In this video, we'll be looking at the final problem from 2023 Special Maths Contest, first round. And it says, for all 2023 combination I, okay, so we explain what this means, equals to 3 to the power of AI times BI, and the GCD of BI and 3 is equal to 1, with AI and BI integers from for I, okay, equals to 0, 1, 2, up to 2023. Okay, so find the largest value of I that maximizes AI. Okay, so we describe what this symbol means. So K represents the number of ways of selecting K items from N items, and GCD of AB represents the highest common factor of positive integers A and B. Okay, so first of all, what do you mean by selecting number of ways of selecting K items from N items? So there's a formula for this. Okay, so let me just make my pen thicker. Okay, so there's a formula for this. So NK, this is equals to n factorial over k factorial n minus k factorial. Okay, so let's see what we can do. So something else I'm going to talk about is periodic value. So if you have periodic value, so periodic value of a number t, so p is a prime. Okay, so equals to some, let's say r. So this implies that, so we're all talking of positive integers here. So this implies that e to the power of r divides t, but e to the power of r plus 1 does not divide t. Okay? So this basically, we're looking for the highest prime power dividing the number. So basically, before we talk of the largest value of I, so this is interesting. So basically, it means there could be more than one possible value of I that, gives us a maximum, but we want the largest value of I that maximizes this AI. So basically, the first problem we want to solve is we want to find the periodic value of 3 in this. So 2023 I. Okay. Want to find the periodic value of this. Okay, so maybe in terms of I, and then we look at the largest I that satisfies it. Okay, so how do we get this? So first things first, I'm going to show. So when I'm going to show that the periodic value of 3 is equals to the periodic value of 3 in I plus 163 combination 63. Okay. So we're going to try to show this. So how do we show this? So I'm going to scroll down a bit. Okay. So let's talk about some few properties of periodic value. Okay. So let's say we have something like periodic value of 3 into 3 to the power of k plus some t. And t, the GCD of t and 3 is equals to 1. So this means that the periodic value of this is going to be 0. Okay. Because 3 does not divide this at all. Then something else I can say is that the periodic value of A times B, so this applies to any prime, is going to be the periodic value of A plus the periodic value of B. Okay, so I'm going to see how we can apply these properties. So of course, you can always do some extra reading about periodic value on your own. So we're going to see how we can do this. So first of all, let's consider this. So let's look at the periodic value of 3 into, okay, so 2023 combination I divided by I plus 163, well, 163. Okay, so let's look at this. So let's simplify what we have in this bracket first of all. Okay, so 2023. Okay, so I'm just going to use a different pen color. Okay, so 2023 factorial over I factorial 2023 minus I factorial, okay, times, so this will be 163 factorial. So I'm just going to invert this immediately, and I factorial times I factorial divided by I plus 163 factorial. Okay, so that's what this thing in the brackets equal to. And let's see how we can simplify. So I factorial can cancel out with I factorial. And so we can slow down a bit. So we can look at the numerator, and so we have, so from 2024 minus I. Okay, so when we cancel this out with what we have in the numerator, we have from 24 minus I, times 2025 minus I. So just keep on adding one until we get to 2023. And then divided by, so when we cancel the 163, we just have 164 minus 165 up to times 163 plus I. Okay, so what can we do from here? What can we do from here? So we can simplify this. Okay, so okay, so we can look at this as 2020. So okay, so let's rearrange it this way. So okay, so this is equal to 2023 over 164 times up to times 2024 minus I over 163 plus I. Okay, so this is going to be equals to, so we're going to try to do some shift. So this is going to be 2187. Okay, so we have 2187 minus 164. Okay, 207 minus 164 divided by 164. Okay, and we can do the same thing. Okay, so 2024 minus I can say 2024. So that's going to be 2187 minus 164. So plus 1 minus I divided by 164 minus 1 plus I. Okay. So this is going to be, so this is going to be same as, so basically we're looking at the product. So 2187 minus some J divided by J. Okay. And J is going to go from 164. So J is going to go from 164 to 163 plus I, basically. Okay. Okay, so j is going to go from 164 to 163 plus I. Okay, so basically we have so let's just confirm that this works. So we plug in 163 plus I. So 2187 minus 163. Okay. This is going to give us 4202. Okay. And then so when we plug in 163 plus I here, basically gets 2 2024 minus I over. So the other denominator is going to be 163 plus I. Okay, so that checks. So why did we do this shift? Okay, so first of all, 2187 is equals to 3 to the power of 5. Okay, so this helps us a lot. So let's scroll down. So now we want to consider the periodic value of 3 in this product. Okay, so from j equals to 164 to 163 plus I, 2187 minus j divided by j. Okay, so I want to consider the periodic value of 3 in that. Okay, so recall that periodic value kind of behaves like an indices. So this is going to be equals to the sum of the periodic value. So the sum from j equals to 164 to 163 plus I. So the periodic value, so of this sum, periodic value of 3 in 2187 minus j, okay, minus, okay, periodic value of 3 in j, okay. So pay close attention to this. So recall that we said, periodic value of 3 in A times B is equals to periodic value of 3 in A plus periodic value of 3 in B. Okay. So a similar thing can be said, periodic value of 3 in A over B is equals to periodic value of 3 in A minus periodic value of 3 in B. Okay. So it kind of behaves like, logarithm. Okay. So can read more about periodic values here. Okay. So we can replace 2187. So we can replace 2187 with 3 to the power of 5. Okay, so recall that I ranges from 0 to 2023. So that means that J will range from, since J ranges from 164, so J range from 164, now is 0 to, so J is at most 163 plus uh, I. So J is going to be, okay, so let's put it this way, so it makes more sense. So we have I is less than or equals to 2023 and less than 0 is less than equals to it. So we have so if we add so J is we know that J, the lower bound of J is 164. Okay. And the higher bound of J is 163 plus I, okay, which is equals to, so I is at most 2023. So this is equals to 2186. Okay. So J is not so J is less than 3 to the power of 5. Okay. Now recall what I said. Since 3 divides this guy here, but since the PRD value of 3, okay, so yeah, think on that property of PRD values I need to mention. So for instance, look at the PRD value of 3 in let's say 9 plus 3. This is going to be just the PRD value of 3 in 9, okay, because that's the highest power of because 9 is the higher power, so which is going to be 2. So why? Because you can factor out sorry, it's going to be the PRD value of just 3 in 3, because 3 is the lower power, so which is just going to be 1. So this is because you can factor out 3 here, so this is 3 plus 1. And as long as they don't sum up to a power of 3, so as to increase the PID value, this is not going to be a multiple of 3. Okay, so basically, let's put it this way. So for most cases, so it's equals to the mean of the PID value of P A by the value of B. Okay, so for most cases, so this only doesn't work when you have something like say let's say m minus some c times p to the power of k, and rather if you have something like p to the power of k minus some t times p to the power of s, and then plus t times some p to the power of s. So that when you add these two together, you just have p to the power of k times p to the power of s. So this is the only time it doesn't work, but we don't have such a situation here. Okay, so you want to be careful about this. So I'll just put most times. Okay, but we don't have such a situation here. So that implies that uh, we can just quickly say, so this is either plus or negative. Okay, so it just doesn't matter. So we can simplify to this. We add the value of 3 in just j. So positive or negative, we don't really care. Just be the value of j. Okay. So this is going to be equals to 0. Okay. So basically, what we've shown is that the PID value of 3 in 2023 combination I is same as the PID value of 3 in I plus 163 combination 163. Okay, so means we can, we can just consider this. So now we just want to look at this, the PID value of I in this. So I plus 163 combination 163. Okay. So this is same as the PID value of 3. So remember, we want to like maximize this. So this is the same as PID value of 3 in I plus 63, I plus 163. So times I plus 162. Okay, so up to okay, so let's do it this way. So this is same as I plus 163 factorial divided by 163 factorial plus times I factorial. Okay. So this is going to be the periodic value of, so we have I plus uh, 1, I plus 163. So we cancel out the I factorial. So we have I plus 163 times I plus 162 up to I plus 1. Okay. So I'm canceling out the I factorial out of it. 163 factorial, 163 factorial. Okay. So now we can just concentrate on the numerator because the denominator does not have an I in it. So we want to maximize this numerator. We want to find the I. So we want to find I that maximizes uh, this. Okay. So, um, so to do this now, so something else I'm going to point out is, so if you look at this by Pigeon, okay, so by Pigeonhole principle, let's look at this. So how many factors we have here? We have 162, 163, 163 terms being multiplied out. So 163 consecutive terms. So have I plus 163, I plus 162, up to I plus 1. So we have 10, so we have 1 up to 162, 163. Okay. So now, for us to maximize this, like, maximize the power of 3 that appears here, we know that 163, so 163 is congruent to 163 is congruent to 1 over 81. So we can look at maximizing the number of multiples of 81. So 81 is 3 to the power of 4. So we can first of all look at maximizing the number of multiples of 81 that appears in this product. Okay. So since 163 is so 163 is equals to 81 times 2 plus 1. So by Pigeonhole principle, it means at most 3 multiples of 81 appears here. Okay. So it means we want if so for 3 multiples of 81 to, and there's only one possible way it can appear, that 3 multiples of 81 can appear here. That's if the first and the last terms, okay, are both multiples of 81. Okay, so basically we want I plus 1 to be congruent to 0 mod 81. So we want I to be equal to some 81k minus 1. Okay. So 81k minus 1. So basically we now restructure the problem to, so I'm going to just write this from the back. So the PID value of, so the PID value of I plus 1, I plus 2, up to I plus 163. So when we plug in I equals to 81k minus 1. So we want to, so maximize for k. So remember, for when we get the maximum I, we also get the maximum k and so on and so forth. So we want to solve for this. So 81k into 81k plus 1 up to 81k. So plus 162. Okay. So now we just need to concentrate. So aside the term, so for 81k plus t, if 81 does not divide t, then the PID value of this, so if 81 does not divide t, then this implies that the PID value of 3 in 81k plus t is just equals to the PID value of t, of 3 in t. Okay, so there's nothing much we can do to like maximize these terms like this. So basically, the k that maximizes this is same as the k. So I'll just put arg max. Okay, so basically the k that maximizes is the same as the k that maximizes. So just look at 81k. So the PID values that we are not so sure of. So we have 81k times, okay, so I'll just put it in bracket, 81k plus 81, okay, and then 81k plus 162, okay. So that's also going to be the k that maximizes this. So basically, if we do away with the 81 for now, so it's going to be with the same as the k that maximizes this, k plus 2, okay. So now we need to keep track of, our variables. So recall that, so I is less than or equals to 2023, less than or equals to 0. Okay, so when we plug in k here, so 0 less than or equals to 81k minus 1 less than or equals to 2023. This implies that 0 is less than, so 0 is less than or equals to, okay, so first of all, yeah, if k is 0, we'll get a negative number, so we can't have k is 0. So we have 1 less than or equals to k less than or equals to 24. Wait. So if you plug in a value greater than 24, we'll get something bigger than 2023. Okay. So now, so we want to maximize this. Okay. So it means the values that of k that satisfy this. So this range of 1 to 24. So we have 3 numbers. Okay. So 3 consecutive numbers. So it means at least one of them is going to be a multiple of 3. And one of them is going to be a multiple of 9. So because of these values of k. So we can have a multiple of 27. Okay. So it means the PID value of this is always going to be, the PID value of this is fixed based on the range of values of k we have. The PID value of this is less than or equals to, sorry, it's not fixed. It's less than or equals to 2. Okay. So it can be at most 2. That's if a multiple of 9 appears among these 3 consecutive multiples. Okay. So we can have k equals to 7. So k equals 7 basically is the minimum k that maximizes this. So now the reason why I'm going to tell you why I'm picking the minimum k for now is because remember, so we want to pick the maximum I. Okay, we want to pick the maximum I. We can as well pick the minimum I, and then we know that this is equals to 2023 minus I. Okay, so we can as well pick the minimum I. So now if k is equals to 2027, if k is equals to 7, that implies that I is equals to 81 times 7 minus 1, which is equals to 566. Okay. So if it means this is the minimum I that maximizes this. So it means if you want the maximum I, so that's we're just going to do 2023 minus 566. So 2023 minus 566. Okay, so we have 30 minus 6, 7. So I have 11. So this is going to be 19. 11 minus 6, 5. And then 19 minus 5 is 14. So we have 1457. It's our final answer. Okay. So we use some properties of PID value, which I'll just run over again. So basically 1457 is our final answer. So let's look for what 1457 is. That's option E. Okay. So just a recap of what properties of PID value we use. So PID value of P in K equals T implies that P to the power of T divides K, but P to the power of T plus 1 does not divide K. Okay, we're talking of integers here. Then we spoke about PID value of P in A plus B. So most times it's going to, okay, I think more of a term I use. So let's say P to the power of some K. Okay, so this is more what I use. So P to the power of K plus some T, okay, is equals to the PID value of P in T. Okay. If 0 is less than or equals to T less than P to the power of K. Okay. So this was the property I used. But then I also spoke about how the PID value of P in A plus B most times is equals to the minimum of the PID value of A and the PID value of B. Okay. Then something else I used was that the PID value of P in A times B. So this one is always true. The PID value of P in A. So just basically how logarithm behaves. And the PID value of P in A divided by B. So that's if A divided by B is an integer. Because if it's not an integer, it's just automatically going to be 0. It's going to be the PID value of P in A minus PID value of P in B. Okay. So that's it. And I hope you enjoyed this problem. I hope you learned something new. So don't forget to like, share, comment, and subscribe. And see you in the next video. Goodbye, everyone. Cheers.